Shravan, as I am trying to delve deeper into the future of work and it's what it means for so many different industries out there, I'm thrilled to have a guest who's going to be deciphering astrophysics for us, what goes on in the realms beyond what is easily known to all of us as humans. It's a delight to have with me Shravan Hanasoge, who is an IIT Chennai graduate, went to Stanford for his PhD, and then did a postdoc at Princeton, is now in Bombay and is teaching at TIFR, in addition to being a professor with NYU Abu Dhabi as well. Shravan, firstly, thank you so much for doing this and really looking forward to learning from you and being able to hopefully share some of your insights with the rest of the world. So thank you firstly.
Well, thank you very much for having me, Vibha. I'm very happy to be here.
Okay, terrific. Thanks. All right, so Shravan, to start off, if you could just please elaborate on a little bit of what you do, a little bit of your journey so far, and what really is your work?
So a lot of my work is focused on understanding. Sorry, my apologies. Apologies. Is on understanding the internal structure of stars. So I started off actually studying the sun in detail, and then now we move to understanding basically all of the stars in our galaxy, or a large fraction of them. What are they doing? Are they like the sun? What's driving them? What is their physics and stuff like that? So this is the broad focus of my research. Over the past several years, I would say the last 5 years, much more intensely, and maybe I started working on it about eight years ago, is machine learning has made an extremely significant presence in my group. So almost all of my kids, basically, or my students, are working on applying machine learning to accelerate the discovery of new physics. And we think basically machine learning, we think we know now that it can dramatically improve, like it substantially improves the accuracy, or maybe, no, sorry, let me rephrase, let me take a step back. The accuracy is comparable or sometimes better than the best methods available, classical 20th century methods. Speed up can be many orders in magnitude, between 1,000 and 1,000,000,000 times, depending on what you're doing. And it requires no human intervention. Once you train a machine, it's done. You can just step back. So, there are all of these missions, billion-dollar missions. Kepler was a very famous satellite that was launched by NASA and ESA. It discovered all these exoplanets orbiting. That's what it's known for, but it's also got a very nice sample of stars. But there's 20,000 of them, 200,000 in total, but 20,000 of very high quality. But now there's going to be another telescope that's launched in 3 years, another billion-dollar instrument called Plato. And the state of art in terms of analyzing these data has not changed. So, when you had one sun, you could use 20th century methods, and that was fine. But when you have 100,000 suns to do this, or millions of suns, if you will, millions of stars, to analyze all of them with the same slow method is just not possible. And so and what's remarkable is that no one is actually...
Sorry, can we stay on like a little more on what you actually do? So when you say you study the stars, what does that mean? We'll just go slowly and then we'll jump into trends and that.
Sure. Yeah. So, I mean, these stars are balls of gas, basically, and they're all vibrating, just like any ball of gas or any balls, that you have, they vibrate. And by observing their vibrations, so every time they vibrate, or, as they vibrate, there are minute scintillations in the luminosity of the star. The photons that are coming are either it's growing slightly dimmer, slightly brighter, like 1 part in a million or something, very, very tiny fluctuations. But this is the accuracy or the precision of the photometers on board these satellites. They can measure these minute changes. Those oscillations are just like the resonances of that star. Just like if you hit a little metal ball, you can hear the sound, right? And so those are the resonances of that metal ball. And so, once you heard, if you tap a little ball, you can sort of tell, is it a metal? Is it made of wood? Just by the frequency, right, of that ball. How big is the ball? If it's very big, then it'll have lower frequencies. If it's very small, it'll have higher frequencies. So you can sort of make all of these determinations very quickly. And the same concept applies now to other stars as well. So we understand, based on their oscillations or the resonant frequencies of that star, we can tell a lot of its internal properties. And so far, there's been a lot of instruments to study the sun. So we know the sun very well, but over the last 15 or 20 years, we've started looking at other stars.
I see.
And of course, there are 300 billion stars in the galaxy. So that's a lot more stars than the sun. And so you need to move with the time. So sorry, so I won't, that's what
Okay.
I do.
Understood. Okay, fine. So you move from the study of the sun to the study of all these other stars. You're saying there's about 3 billion stars out there. And
300 billion in our galaxy.
300 billion, 300
Yes.
billion stars in our galaxy.
Yes. That's
And
a lower bound.
that's a lower bound. Okay. And
Yes.
you're saying there hasn't been that much research and work done, obviously, on the rest of these 300 billion. And that's where you're trying to shift your research to.
Yes. Yes.
Okay, great. Okay, cool. All right, thank you. That's very clear. And let's go back now to what you were saying about, the advancements in technology. You touched upon machine learning
Yeah.
as one of these advancements. And you were touching upon the invention of certain telescopes. So let's go a little bit deeper into that and understand how that impacts your research.
Yeah, so a lot of the highest quality data are all space-based data. So these are expensive to launch. They're launched by, of course, nation states like the US, and even India is now joined with Aditya L1, and ESA, which is the European Space Agency, JAXA, which is the Japanese Space Agency. Also, all of these collaborate, and they build instruments and so on. And so the launch cost, including payload, all of this is like upwards of $1 billion. And JWST, which is the most remarkable James Webb Solar Space Telescope, was a $12 billion, for instance. So the solar missions are much cheaper, but still the flagship solar missions are about $1 billion. And Kepler was an extremely expensive instrument that was launched 15, 20 years ago, transformed our understanding of planets and stars. And before that, we thought only very few stars had planets. And now we're increasingly thinking basically every star has a planetary system around it. So that changes, our ways of thinking about a star formation, a planet formation, life on other planets, and so on. It just changes everything for us. But so Kepler was very, well known for the planet they're called exoplanets, extrasolar planets. But it's also got very high quality measurements of stars, so you can understand stellar physics too. And
And this came out, you're saying, about 10 or 15 years ago.
This was launched in about 2007 or 6, I think.
Okay.
And the problem is that when Kepler was launched, a lot of the methods that were used to analyze 200,000 stars that Kepler detected, of which 20,000, as I said, are of relevance directly to me, for instance, they're all identical to the same methods that we used for the sun. And those methods are slow. They require a lot of human intervention, and not any human. A very educated and specialized human has to intervene and constantly check that everything is working okay. And it's very computationally intensive. And so these are dumb algorithms, so when I say dumb, they're very sophisticated. But let's say I apply it to one star. I spend, I don't know, hundreds of.
You're saying they're recurring algorithm, like you're basically repeating the same function over
Yeah,
and over.
exactly. You're doing the same thing from star to star, and you're not learning anything from one to the next. It's the same thing. You start from exactly the same place every single time. You spend all of this effort and you've learned nothing. Like you, as a human, have learned something, but the machine so the algorithm hasn't developed. And hasn't said, okay, well, this is sort of how it looks like, and this is what it means. If I see this is what. So sorry to anthropomorphize the algorithm, but that's what it ought to be doing, right? So it ought to learn from its previous from the previous instances, and it doesn't seem to. It doesn't seem to. It does not. It is not designed with this function in mind. So, and interestingly, since that time, there have been other satellites that have been launched. There's another one that's going to come up, as I said, in a couple of years. But there's a tremendous inertia in science. No one wants to change their methods. There's inertia is everywhere. It's not just science, but humans run science, and they have a lot of inertia. And they haven't said, okay, well, this is a very different problem from studying the sun. So we need to develop altogether new methods to do it. Every meeting, every conference I go to, they say, oh, machine learning will take over, and this, that, and the other. But it's just all lip service, because they're not saying, well, we need to really dedicate some effort to doing it. So we're among the only groups to do this. I would say we're the only group to do this seriously in the world. And so we're hoping that we can capitalize.
Currently I understood there's two problems. One is like the actual launches and the equipment, these telescopes.
Yeah.
So let's compartmentalize into these two, since you brought up two, the telescopes and then the algorithms and the machine learning component. So
Yeah.
in terms of future trends, if you had to sort of prophesize the 10 or 15 years into the future, let's talk about changes you're seeing or developments you're seeing in both. And you start with whichever one you're comfortable with.
So let's say in terms of space-based telescopes, I mean, these are very expensive to conceive and launch. They take about 10 or 15 years. Now, which launch vehicles are becoming rapidly cheaper, right? So you have SpaceX and you have all of these other, now ISRO is getting into the thing. And so once the reliability of alternate launch vehicles is widespread, then I would imagine that that reduces the cost component quite a bit. And so it's still just the instrumental design. And the first time you do it is the most expensive. These are very sophisticated telescopes. So in the design of these telescopes are probably breaking new ground in terms of technology. But okay, now they've done it, right? So the next time around that they do it, it'll be easier, it'll be more cost effective. They have engineers who know this stuff. So the hope is that in 15 years or 20 years, we will have extremely sophisticated telescopes looking next generation telescopes looking at the galaxy and looking for life, looking at stars, looking at planets, all of this type of stuff. And hopefully each time they do it, it gets a little easier, it gets more cost effective, and delivers new science. So that's the part of the technology. I'm not directly involved in the technology development. It requires a very different, sort of progression. You
And
need
on the machine learning front, are you seeing more algorithms and more machine learning come into the space overall? Not specifically your work, but just generally the space, if you were to speak.
Oh, sure. Yeah, yeah. So machine learning is playing a role. I still think, so there are different ways also that you can use machine learning. There is the crude way, what I call crude, which is that you use it as a tool to classify things. Or is this galaxy a spiral galaxy? Does it have this feature, that feature? Like image recognition, right? So that's what I call a crude. I mean, it's still very powerful, but it's crude. Or like, they have all these huge ground-based telescopes that are going to come up in the next decade. They're going to take petabytes of data a day or something, enormous amounts of data that they're going to capture about, the stars and the galaxy and so on, extragalactic, like outside the galaxy, all of the sky that they're going to survey. And so you need a very rapid algorithm to go through all of these and say, well, we'll discard all of this and we'll keep this type of stuff because this stuff is relevant, right? So they have that type of I think those are the primary ways that machine learning is used. But it's sort of the stuff that I am doing. I think not too many people are applying it yet.
Okay.
And the hope is that, yeah, sorry.
Okay, so you touched upon technology. So this is technology advancements, right? In terms of machine learning and then the actual machinery. What else? What else is affecting this this overall space of space exploration and astrophysics? Like what are the other factors that you're seeing playing into the future of this space? Is there a sustainability component? Is there a geopolitical component? What are some of the other factors at play?
So in terms of physics itself, science itself is an international venture, but there's a space race. There's really a very definitive space race, and there is geopolitics in that. And India has thankfully made it across the, I wouldn't say finish line, but they've certainly they've done well for themselves. And so there is a significant geopolitical component, and it is crucial that for the coming decades, we maintain access to space independently. We do we have all of the technology to launch our own satellites and things like that. So that I think is a very important thing. What India still lacks profoundly, and even geopolitically, you want the acumen, you want trained engineers to be able to do very sophisticated optics, to build in these instruments. It is not a trivial thing to build some of these telescopes. You have very high precision technology, and we're
Well,
not there yet at all. Like
I
at
want to
all,
stay
at all,
on,
at all.
if we could stay on geopolitics, could you just elaborate,
Yes.
like, what exactly is going on? Who's winning, who's losing, and how does it play out in space?
Yeah, so I mean, for instance, I mean, it's not yet clear who's winning, who's losing, because there's lots and lots of players now. There are so many different technologies now to launch spacecraft into orbit. So the ones that we typically hear about are things like, you have propellant, and then it burns, and then this thing lifts up and goes. But there's all these other things like ion-based launches. There's a slingshot launcher, like a centrifuge. Like it starts spinning the spacecraft faster and faster and faster, like almost vertically, and then it just lets go. So it just throws it out by centrifugal force. It's launched into space. Many, many different technologies now Who's going to succeed? Who's going to not succeed? That is an entirely unclear thing yet.
I'm not trying. I'm not still clear on what is the geopolitical angle. Are there some countries who say that, oh well, this part of space is ours? Like, has it been demarcated? Territories
Yeah.
demarcated? Like, what is the geopolitical angle?
So okay, so there's no. So this is a tragedy of the commons. That is one of the issues there is, right? So it's literally like the ocean. The space is available to everyone. No one is free, of course, to access, but it also means that you can pollute the hell out of it, just like you do the oceans. And so the most important region for most satellite operators is the low Earth is the low Earth orbit, LEO as it's called, and that's between about 300 kilometers above the Earth's surface to about 1,000 kilometers. So that's the general range. It's populated by a ton of spacecraft, and there's going to be a million spacecraft over the next some number of years.
Wow. Okay.
Starlink there are now 7,000 operational satellites roughly, compared to like a few hundred a few decades ago. So, and then it's going to increase dramatically, right? India has launch capability. Elon Musk has launch capability. US, all of these countries are launching their own things. There's OneWeb, which is like a fleet of satellites for internet. There's Starlink. There's Kuiper, which is Amazon's 5,000, 4,000 satellites. There's Geo, I think, is going to get into it
I
too.
see.
They're going to
Okay.
launch their own thing. So all these guys are going to launch their satellites. There is and there's no real central body, because who's going to enforce this stuff?
There is no central body.
There's an international astronomical, something federation or something, but they can do stuff, till the cows go home. But are people going to listen? I mean, this is a real question, right? This is a very complicated thing. There's no penalty. There's no penalty for mistakes. It's really literally like the ocean. You could go pollute the ocean, and
Oh,
once you're outside in international waters, there's no international body with any power to regulate this stuff. And so they call it the Kessler syndrome. What happens is you have a lot of debris and you have a lot of spacecraft. And as a number of spacecraft go on, and then if they're not decommissioning these, the correct way to decommission a satellite is that it powers down, and then it drops into the Earth's atmosphere so that it burns.
hmm.
Re-entry burning. That's the correct way to decommission the satellite and get rid of it. So I think a lot of people do it, responsible people do it, a lot of people don't do it. So then you have all of these objects, defunct objects that are just flying around. And as the number of objects increases, suppose two or three of these objects crash, then you have many more objects. And then those many more objects will hit many more objects. And then it becomes this exponentially growing chain. And we will no longer even have access to space at that point. So this is called the Kessler syndrome. It was predicted by a guy a few decades ago. And we're not close to it yet, but it doesn't take much to get there. India did something very stupid a few years ago. They did this, forget what it's called. It's like Star Wars, right? Like they took a laser beam and shot a satellite in space and breaking it up into like 1,000 pieces, which is absolutely terrible. China was the worst. About 2 decades ago, they did the same thing to test their capability of like destroying a satellite in space. And then
And,
they,
and going forward, are you going to see more and more countries doing this in the future? Smaller countries coming into the picture and saying, "Oh, we want
yeah,
to now
yeah,
establish."
yeah, I think everyone wants to launch now. I don't know what small means. Like the UAE has a space agency, Saudi Arabia has a space agency. They also want to get in on this. Richer, smaller countries really want to get into this. It takes a while though. It's not an easy thing to launch into space, so I don't see them immediately. But Saudi Arabia will attract people by paying people lots of money. So I don't know. I can't tell you in what time scale.
What is it for these countries, right? From a geopolitical perspective, what does it give them when they're able to launch a space mission? Is it the credibility? Because there's no natural resource that they're bringing back, right? There's no direct capitalist uh, return. So
There's
what
an, there's
is
a,
it?
there's a shorter term goal, which is that they can build their own satellites and then they launch them, and like, communication satellites, GPS satellites, Earth observation, all of this stuff they can do. But then on a sort of more significant, they're defense satellites, right? Like if they want to have a defense satellite that's I don't know, doing all the spy work. They can do all of that stuff. They want independence. So that's the shorter term, immediate goal. Because right now they're dependent on the US. If the US or one of these countries, right, the US gets upset with Saudi Arabia and says, "Well, sorry, buddy, we're not going to give you this. We're not going to give you that." No one wants to be dependent on another country because then it's geopolitics. But the more long-term thing is asteroid mining. They want, asteroids are supposed to contain tons of minerals and all of this stuff, which is estimated to be a multi-trillion-dollar economy. So that's the longer term goal. Moon bases, Mars bases, all of this type of stuff.
I see. They want to have their own bases on the moon and on Mars.
Yeah, yeah.
Okay, cool. The geopolitical is very interesting. Looks like there's no regulation. Look like there's no one country or one governing body that's handling all this. So
Yeah.
a little bit of mayhem going on in space right now from what you're describing.
Yes.
Okay, and you touched a little bit on the sustainability angle, and can we go a little bit deeper on that? When you were saying that they're out, you said something, they're out there polluting space. So
Yeah.
can you elaborate a little bit on this sustainability angle of this whole thing?
Yeah, so I mean, till about 10, 15 years ago, people didn't take the space debris stuff so seriously. So there's a lot of satellites just hanging around, a lot of pieces of debris. There's 16,000 pieces of debris that are larger than 10, maybe 21,000 pieces of debris larger than 10 centimeters in size. These are traveling at 7 kilometers a second. So they can rip a hole through your satellite in 1 second. I mean, if they touch your satellite, they can rip a hole. And then those are, but then you have millions of objects that's smaller than 10 centimeters. These are orbiting space, and then they're just going to orbit for a long time until they eventually lose their momentum and then come through to re-entry and burn. So they're polluting space. So when you want to launch something, you have to wait for a clear window because you don't know there's debris there, there's a satellite there. So even finding launch windows is not. It's not like, okay, well, I just decided the winds were clear today, so I'm just going to launch. It's not just that. You also have to make sure that there's no debris in your trajectory.
Wow. Okay. Wow. Okay. There's lots of implications. Okay.
Yes.
What are you seeing going on in the future? Are you seeing space travel becoming a reality? Like, what are some of the big changes that are coming? Are there going to be hotels on Mars that they're predicting, passenger travel to these planets, etc.? Do you think this is all a fallacy, or do you think this could actually genuinely become a reality in 10 to
Well, it
15?
already is a reality. There are people, pay $80,000 or $100,000 to go to the edge of space. I don't know how many kilometers that is, but they already do it now. So I think Virgin does it. I don't know what Amazon's doing. The Project Blue, they keep saying I think they did. No, Jeff Bezos went up, and so they're all doing it. They're all doing it. I think it's terrible because environmentally, it's it's very, very bad for the environment because you're releasing all of this, carbon emissions, and these are not a small amount of carbon, right? It's like you got to move into space. But it will become a thing. It will. There's a lot of rich people who don't care about the planet and who just want thrills, and so they will make it a big thing. And I mean, hotels in Mars is a while away, but I don't know what a while away is. It all depends on how technology is moving at an unprecedented pace, right? I mean, this is the singularity. You've heard of the singularity? I mean, this is what the Ray Kurzweil predicted a while ago. I mean, you see it in AI, and I don't know, like mechanical technology isn't moving quite as fast, but it is moving still. A lot more people are working on it. Compared to 30 years ago, when space technology was the firm, sort of domain of nation-state funded agencies. There was NASA, there was ISRO, there was just, that's it. There were no private companies. I mean, they would supply some components, but that's about it. But now everyone's doing it on their own. So that changes everything. So I think we'll see that. I think I don't know how it's going to be. I don't know how it's going to be. We'll see that.
Okay. So thanks for explaining, the landscape and what's going on. If you were to sort of, it seems like there are many layers to this. So firstly, there's no legislation. So if you were to sort of, propose some sort of like what is needed in terms of legislation to regulate this. So if you were to give advice to sort of the political legal class saying, guys, here's what you need to do. And then the educators, right? What do the educators and that faction need to do? And then the corporations. They're sort of the three tenets of society, right? Like the lawmakers, the policymakers, the corporations, and then the students who are sort of like your new workforce. So let's take each one at a time. And what would you tell them? What from your vantage point?
So I think legislation needs to move first. I think they need to make this a lot more open. Right now, ISRO is, it's obviously very successful, but it's like a stranglehold, right? On the kind. I mean, don't quote me in this exact word, but they are, they do have this control over the space economy in India, and so it's important for the commercial sector to be encouraged more, to have more
In
incentives.
India's commercial sector to be more involved.
Yes, yes, yes. I mean, are you seeing India or you're talking about worldwide? Sorry, let me just ask that before I go off.
Yeah,
You're
yeah,
saying
worldwide,
worldwide?
worldwide. Yeah, yeah.
Oh,
You can
worldwide.
say
Yeah.
world, India,
So
whatever you want.
yeah, sure. Okay, for India, I think we need better legislation to encourage the space economy. America has done it extremely well. They're really doing it. I mean, they're, as always in all of these matters, they're an example to follow. Legislatively, also they think quite seriously. ESA and NASA are thinking very seriously about how to protect against space debris and stuff like that. The problem is ultimately you need a UN with teeth, for space. There is a UN organization for space. So, but it's not that they don't have it, but who listens to the UN anyway, right? So that I think is very crucial. I don't know how we're going to achieve that. I don't know who.
You're saying you need a regulatory body which has
Yeah,
all these countries as member states, and then there's this sort of, okay, you're saying that that's what you would recommend.
I would stronger, but I don't know how to give it teeth, right? So that's the issue. I don't know how they'll enforce anything. So
And
that's
why do you
yeah.
think private sector should come into this space? More private sector.
Private sector is already deep in this stuff. I think they are concerned also. The private sector ought to be a lot more concerned. Ultimately, as you know, with a lot of these things, it has to be a ground up type thing. Of course, the legislation is important, but corporations have to take this seriously. Have to take, the how the maintaining and minimizing, mitigating space debris, this type of stuff. So they do have to take this type of seriously. But I also think they're doing amazing things, and they should continue to do amazing things, develop new technology, make more affordable access to space and things like that. I think would be remarkable. So that's the corporate angle. I mean, there's nothing specific. I think they should continue doing what they're doing, but be more intensely aware that this is a tragedy of the commons that is occurring and set to occur in some grander scale in the next few years if they don't react. And in terms of educators, I mean, we need to teach people about space and science and all of this type of stuff, right? And as I said, exemplify the tragedy of commons and grow a more sensitive youth and sensitize the youth to the problems that can be their lives. It could happen anytime. Huh? It could happen in a decade, 15 years, 20 years if they're not careful. So that's why they need to be aware. It is their earth ultimately. We're all getting older, so they're the ones who are going to be most affected.
So from an education perspective, if you were to suggest any changes in curriculum, right? You've gone through some serious training and degrees. And you're a professor right now. So what sort of changes would you advocate in terms of curriculum to keep pace with what's going on?
Yeah, so I mean, look, first of all, I'm quite old, so I don't know how curricula themselves have changed for younger kids. But we talk about environmental protection. I don't think we talk enough about space environment and like in the protection that it is a legitimate now activity in the country. Just like we use lakes, we use water from here, we use land use, all of this, right? There's all of this stuff in our textbooks about land use, water use, conservation, all of this. But there has to be space conservation also. There really ought to be more of that. There's more of, I think now we know a lot more about the sun and stars. There ought to be a little more training on that type of stuff. How the sun is affecting us in a more quantitative and physics sort of way. So that people are aware of their environment. Their environment is not just the stuff that they immediately see or can touch, but the sun is doing a lot to us. The space is doing a lot for us. So we should be, I think, more sensitized to this sort of thing.
Okay, so you're saying inculcate like sort of the space environment
That's
in
right.
understanding of what the
Yeah.
environment even entails, because it's
Yeah.
sort of limited
Yes.
purview.
Yes.
Okay, wow, that's a very interesting point. When you're seeing these sort of changes occurring, what sort of new job sectors, what are you seeing coming up? And these could just be a figment of your imagination, but like in 10 or 15 years, what do you imagine as new categories in space research and in just, what all could come through?
In terms of astrophysics, I mean, I think, as I said, there are all these instruments that are being launched. So I think it's going to be extraordinary. One of the most extraordinary things that people are saying we're on the verge of, but it's really not clear because I'm not really in the thick of things. I don't know. But there's a couple of groups that have claimed that they're one inch away from detecting life somewhere. I don't know. I mean, okay, now take this with a grain of salt. Don't say that I said this, but this is what people say. They've detected all of these chemicals, organic compounds in the atmospheres of distant planets that can only come from an organic source. So anyway, you need all these instruments that are going to look at these exoplanets more closely and see if that's actually what's happening and so on. So there's a lot of really exciting science in terms of astrophysics. We've not even, people don't look at the sky, and this, as I was saying to you before, the sky is disappearing because of all of these satellites and light pollution and all of this. But I mean, it's an extraordinary universe, right? So there's so many interesting things happening. So in terms of astrophysics, I think better instruments equals a much deeper understanding of who we are, where we came from, how this peculiar set of circumstances, how we were dropped into this peculiar set of circumstances and so on. So I think there's some deep stuff to come. For science, I think there's work. Now, for non-science, with machine learning and stuff, it's a lot trickier. I don't know what's going to happen. A lot of white collar jobs could just vanish into the mist. People say this, people say the opposite. It's hard to say.
So in your space, you're saying, you will need the actual engineers. You'll need the aeronautical engineers, you'll need the spacecraft engineers, the mechanical engineers. You
Yes.
don't see that part dissipating because you're saying there's a lot of work to be done.
Yeah.
A lot of investments coming up already planned.
Yeah, because it's all highly specialized, highly technical work. It isn't something that we've codified and really understood extremely well, right? So each of these instruments requires a dramatic amount of novelty. Machine learning can help, but it's not in this position where it can lead, not yet.
Okay.
But given how like a year and 3 months ago we didn't know the existence of ChatGPT, and here we are today.
Sure.
Who knows, right? Who knows what's going to happen? Maybe I'll be out of a job in 10 years. I mean, figuratively speaking, who knows, right? I mean, I don't
And
know. I don't know.
what about other new job categories, right? So if space travel actually becomes so accessible,
Yeah,
what sort of like, how they go, are you going to need lawyers? Are you going to need regulators? Are you going to need policy makers? Like,
that's right.
what are other, sort of follow
Ecosystem.
through
Yeah. Yeah,
industries?
yeah, you're exactly right. There's an entire ecosystem around space that needs to be built in terms of, in addition to the engineering and manufacture of space payloads and all of that type of stuff. I think you need exactly as you said, you need policymakers attuned to to all the issues that are facing us. You need lots of people you need pilots, you need specialized training to handle this. Materials research, because we want to be able to push these aircraft into there's a pushing our materials pretty hard. So there's a lot of really, I think, important jobs that are going to come up.
Geologists, maybe, because once they start discovering more and more, someone's got to understand these materials also.
That's right. That's right. Geology for asteroid mining, for landing on Mars, understanding the rocks there. Astrobiologists to see if there's
Life.
life on other planets and even in our solar system. Now, the one that I keep my eye on, which is one of the most fascinating things, is Io, Europa, which is one of Jupiter's moons, and I don't know, it's a really interesting planet, actually. It's not that far, it's very far from us, but it's not as far as an exoplanet. And they're getting satellites closer and closer to it. It's volcanic activity, there are oceans, people have speculated there may be life under the crust, So, I mean, there are all these movies, right? Like where people go to Europa. There's this fantastic movie where someone's going. Like, I think that'll be a reality at some point. I don't know when. I hope in my lifetime, because that'd be amazing to see what's there.
Okay.
So in terms of exploration, human exploration, I think is truly reaching a new phase. That to me is the most exciting.
Okay, and so many jobs as a follow through of what
Yes,
there is a lot of, it sounds like there's a lot of activity, there's a lot of money being spent,
that's right.
there is a lot of interest because people are trying to dominate one planet, but if you're now suddenly able to expand
Yes,
this into such a humongous space, then
yeah,
obviously there will be a space war, and
that's right.
at some point it looks like it'll start to lead to territories and sort of claiming areas. Right now you're saying it's all open, right? Nobody owns anything. There is no
Yeah,
conversation around any ownership per
that's
se
right.
as of
I
yet.
mean, there's no question of ownership because but there should be there are conversations. There ought to be maybe much more serious deliberation on protecting this common space. There's no way to demarcate that space, just like international waters. You can't say, well, it's mine. So, and certainly the smaller countries won't have it anymore, right? This time of colonial superpowers is over. So,
Hmm.
yeah,
Okay. So last question before we close
yeah,
off. Let's talk a little bit about, like, one of the chapters in the book talks about optimism versus pessimism. And
yeah.
everyone's been sharing sort of like a really optimistic scenario in their space, where in your space, where you talk about like, oh, here's what it might look like, and it's amazing, like what we might see. And then here's a doomsday scenario of how like things could go drastically wrong in the future. So let's start with optimism. What's the optimistic scenario on space?
The optimistic scenarios, we get climate change under control. We find technologies, we find ways to become not emotionally connected to it and fighting about whether or not there's climate change, but simply limiting our carbon emissions, to treat it as just any other problem that we have, pollution. We get all of those things under control. We're like more civilized as a as a race. That is one I think positive way, and then that extends, of course, to space, right? So we're careful about space and manage it well and live in a more harmonious way. We have satellites, we have incredible space exploration, we have tools to go to space, but use them wisely, not just like, oh, some rich guy wants to burn some fuel and go into space and things like that. Use them wisely for the betterment of the race as opposed to individual goals. So that I see, habitation on Mars, habitation on the moon, long sci-fi goals, right, that are within reach in my lifetime. So that I think is would be a very extraordinary discovery in terms of discovery of exotic life, maybe on other planets. A lot of stuff. A lot of stuff is super tantalizing, is now within reach, and we are not. Yeah, I think, as I said, in my lifetime, I can see these things happen. These were sci-fi goals just 20, 30 years ago. So they're suddenly all within reach. So that I think would be the most exciting thing. Then now the pessimistic scenario, which is also which is unfortunately more probable, is that none of these guys continue to bicker. This Leo gets like jammed, basically low Earth orbit gets jammed with all this junk and like satellites, and everyone's trying to make a quick buck, and they're not trying to be careful about this. And yeah, and then nothing serious happens in terms of space exploration. There's just some idiotic space tourism. But that type of, I think there will be space explorations. So I think even the most pessimistic scenario, there will be some space
What is
exploration.
the pessimistic scenario like? Can there be like some sort of like, with all these collisions and stuff? Can there be a situation where like something drastically collides and then affects Earth? Like what is a really sort of doomsday?
Nothing will affect Earth except that we may not have a space in Leo anymore. We're just jammed. There's like millions of objects, just coming
Floating
up,
around.
yeah, everywhere, and then like you can't track all of them, and so you're done. And then you have very limited opportunity to go outer space, and things like it becomes very difficult, and it just becomes a mess basically.
The collisions and all the material falling off of it, like the debris you talked about, that can't hit Earth and sort of destroy parts of it.
No, I mean there have been a few instances. Those are very rare. Usually they just burn up in re-entry. So what happens is as they keep circling orbiting the Earth, there's fluid drag, atmospheric drag. So they're slowing down. Eventually they spiral in, but on very decadal timescales, multiple decades. Eventually they spiral in and they burn up. There have been two instances where space debris have landed, and no one has been yet killed. But one sheep, I think, was killed in someone's farm. So that's the extent of damage. Someone's house, I think, was slightly broken or something. But generally, that is not a realistic scenario.
Okay, so you're saying the worst case scenario is either the orbit gets jammed and then the
Yeah.
exploration has to sort of halt or pause,
Yeah.
etc.
And then the launch of new satellites, telecommunication, all of this will become a lot harder.
Okay, so that's sort of like worst case scenario.
Yeah. Yeah.
Okay, cool. All right, thank you so much. Is there anything on the closing note? Any advice you want to give to students? Anyone who's interested in your space? How should they be thinking about the future?
I think you should be really open. I think you shouldn't, technology is moving at a pace today that you can't say, well, this is what I want to do. And I mean, you can say that, of course, but you should, in general, it's productive to be open-minded because lots and lots of things are happening. Be ready to pivot, not commercially, of course, but even personally, be ready to pivot in terms of like different topics and what's exciting and so on. That I think is the key to addressing today's world.
Okay, so just stay open-minded and be ready for change because change is coming.
Change is happening. Yes, that's right.
Is happening. Okay, great. Thank you so much, Shravan. I totally appreciate this and look forward to reading more and exploring more with you. Thank you. Thank you so much.
Bye.
Bye bye. Thank you.